welcome back to Techie Talks. In today's video, we're going to look at motion under gravity. Now, when we say motion under gravity, we are basically looking at things that are falling freely. When we say motion under gravity, we are looking at things that are falling down freely. Now, when we are looking at motion under gravity, we use our equations of motion, but those equations of ours are altered, okay? So we're going to say that under motion under gravity, under motion under gravity, the acceleration in the equations of linear motion is replaced by g, i.e. acceleration due to gravity. So this means that our first equation, which is v is equal to u plus at, in motion under gravity, when we are using it becomes v is equal to u plus gt. So our second equation, which is s is equal to ut plus a half at, becomes s is equal to ut plus a half gt squared. Then our third equation, which is v squared is equal to u squared plus 2as, becomes v squared is equal to u plus 2gs. This, now for us, under motion under gravity, we are going to consider these equations where the value of g is assumed to be 9.81 meters per second squared. And then guys, this is the value that we assume, that we shall be assuming in our calculations. But be careful with the instructions on the paper. Sometimes you will find where it is 9.8, and in some cases they will tell you it is 10. But for A level, we use this value unless it's stated otherwise. That's when you can't deviate from not using it. Now, we've been talking of acceleration due to gravity. What is acceleration due to gravity? Acceleration due to gravity. One might be wondering, what is the acceleration due to gravity? Acceleration due to gravity, this is the rate of change of velocity with time for a body falling freely. We are saying that this is the rate of change of velocity for rate of change of velocity with time for body falling freely. Or can say that this is the attraction. This is the attraction on, this is the gravitational attraction. Gravitational attraction on a 1 kilogram mass by the Earth, as briefly as that. So this can be the definition of acceleration. Now, when we say a body is falling freely, this basically means that the rate of change of its velocity is equal to 9.81, and that's when we talk of free fall. Now, let's look at what happens to our equations, and we are going to look at what we call sign conversion. Now, we are going to consider a body that is projected vertically upwards, and then when a body is moving downwards, body moving downwards. Now, when the body is moving downwards, what happens to our values that we know? Because we remember the letters we used. For example, if this is upward motion, the value of u is positive if a body is moving upwards. The value of g is negative and positive here. Then the value of displacement here is positive and it is negative here. Which other term have we left out? Basically, what happens to u when a body is moving vertically downwards? This is also negative. So this becomes our signs that we shall be using in our consequent examples. We shall, for example, if a body is moving, is initially moving vertically upwards, so there is a v that we have not talked about. When this body is moving upwards, what happens to its final velocity? We know that the final velocity is also negative, but then here the final velocity becomes positive if it is moving upwards. So that is our sign conversion that we shall be using in the subsequent calculations that we are going to see.